5-5, standard form. So our objective for this section is to write linear equations using intercepts, or to graph linear equations using intercepts, and to write linear equations in standard form. Essential understanding is one form of a linear equation called standard form allows you to find intercepts quickly. You can use intercepts to draw the graph. So in the previous section, we've looked at slope-intercept form, and previously we looked at point-slope form, which was y minus y1 is equal to m times x minus x1. Okay? Both of these forms have their uses, right? Slope-intercept form is good if you have the slope and the intercept, and is good to graph. Point-slope can be used if you have any point, not the intercept, any point and the slope. So standard form is going to be a form that focuses just on the intercepts of the graph. So in this lesson, you will learn to use the intercepts to graph a line. Recall that a y-intercept is the y-coordinate of a point where the graph crosses the y-axis. The x-intercept is the x-coordinate of the point where the graph crosses the x-axis. So standard form of a linear equation is ax plus by equals c, where a, b, and c are real numbers, and a and b are not both 0. One of them can be 0, just not both. And it is pretty typical in standard form that a and b are also integers, which means no fractions. Okay? So let's find the x and y intercepts of the graph. 3x plus 4y equals 24. Okay? So if I'm going to graph something, if I want to find out where it crosses the x-axis, right, which is the horizontal axis, we can see that if I have a point on that line, that coordinate is going to be some x, and that y is going to be 0. So if I want to know the x-intercept, I can just plug in 0 for y. And conversely, if I want to point on the y-axis, we can see that x is going to be 0. So if I want the y-intercept, I make x equal to 0. Okay, so let's do that. So for the first one, we are going to plug a 0 in for y. Okay. This would give me 3x. 4 times 0 is 0, so it just goes away. It is equal to 24. Divide both sides by 3, and I have that x is equal to 8. Okay, which makes my point 8, 0. Okay, which means the x-intercept is 8. Okay, to find the y-intercept, I now plug 0 in for x. This goes away, and we have 4y is equal to 24. Divide both sides by 4, and I have y is equal to 6, which makes my point 0, 6. And 6 is the y-intercept. Okay? So x-intercepts, you plug a 0 in for y. Y-intercepts, you plug a 0 in for x, and solve the equations. Okay? Let's try a couple more in our got it problems. So the x and the y-intercept. So for my x-intercept, I'm going to take 0 and plug it in for y. Okay? That gives me 5x is equal to 60. Divide both sides by 5, and we would get x is equal to 12. Okay? Which makes my point 12, 0. To get the y-intercept, I plug a 0 in for x. Minus 6y is equal to 60. That goes away. We have negative 6y is equal to 60. Divide out the negative 6. It's okay to get negative numbers. Oops. and y is going to be equal to negative 10, which makes my y-intercept 0, comma, negative 10. Okay. For the next one, same thing, x-intercept. So we have 3x plus 8 times 0 is equal to 12. That's just 3x is equal to 12, so x is equal to 4, which makes my point 4, 0. And for my y-intercept, we plug a 0 in for x. Okay. 8y is equal to 12. Divide both sides by 8 here, and you're going to get a fraction, which is okay. Right? Y is equal to, let's reduce that to 3 over 2, which makes my point 0, comma 3 over 2, which is just 1.5. Okay. Good. So, what is the graph of x minus 2y is equal to 2? So, we could change this in a slope-intercept form and graph the line that way, but let's graph it using intercepts, which is the title of this question, okay? So let's find my x-intercept by plugging 0 in for y. So x is going to be equal to, that just goes away, negative 2. So I can put a dot at 0, comma, negative 2, right there, or negative 2, comma 0, sorry. For my y-intercept, I plug 0 in for x. So that's 0 minus 2y is equal to negative 2. So that's negative 2y is equal to negative 2. Divide out the negative 2, and I get y is equal to 1. Okay? So now put a point at 0, comma 1. Well, I have 2 points, which is kind of enough to make the graph. Okay? So I can make my line just like that. Let's move it. Oh, very good. Okay. Once you have 2 points, intercept points, I can use them to make my graph. Okay. And if you like this way better, you can use this way. The only problem that's going to happen here is if we don't have numbers that work out well and we get fractions. Makes it a little bit harder to graph than one of the other methods. Okay, so first, my x-intercept is 2x plus 5, plug 0 in for y. We get that, so 2x is equal to 20, which makes x equal to 10. So x is equal to 10, goes right there, 10 comma 0. And for my y-intercept, we plug a 0 in for x, plus 5y is equal to 20. 5y is equal to 20. Divide out the 5, and I get that y is equal to 4. And there's my point right there. And now I can draw my line. Okay, so that's graphing using intercepts. So if a is equal to 0 in the standard form, ax plus by is equal to c, we can write the equation in the form y is equal to b, where b is a constant. And if capital B is equal to 0, whatever number is right there, you can write the equation in the form x is equal to a, where a is a constant. If we just have y equal to something, that would have no slope and would make it a horizontal line. And the graph of x is equal to a has an undefined slope. Y is not even there, so that is a vertical line. Okay? So let's graph these. Think about this. X is equal to 3. Always equal to 3. Well, if I put a dot there, okay, well, x is not equal to 3 there, x is not equal to 3 there, or there, or there, or any of these other places on this graph, but x is equal to 3 there. It's 3 comma 1, 3 comma 2, 3, 3, 3, 4, 3, 5, and you can see that when I have x equal to a number, got a little curve there, but when you have x is equal to a number, you have a vertical line. As opposed to y is equal to 3, Now that point is right there. That's 3, that's y3, that's y is equal to 3, y is equal to 3. And you can see now you have a horizontal line. Okay? So when you just have x is equal to a number, it's a vertical line, y is equal to a number, horizontal line. Let's try a couple got it's. Okay? So my got it problem, x is equal to 4. That looks like that. X is equal to negative 1. That would look, whoops, that would look like a line down like that, negative 1. Y is equal to 0. Well, that's a nice horizontal line on the y-axis, and y is equal to 1. That's going to be a line right there. Okay? Because at this line right here, at y is equal to 1, every single point on this line has a y coordinate of 1. And that's a way to help if you can't remember them. So, given an equation in slope-intercept form or in point-slope form, we can rewrite the equation in standard form using only integers. So when I have this equation right here, when I want to put it into standard form, I'm going to make sure that it has only integers. So y is going to equal negative 3 over 7x plus 5. So what I want to do is I want to multiply both sides of this equation by 7. And what that will do is that will make this fraction go away. So over here I have 7y. Negative 3 over 7 times 7 is negative 3x. And 5 times 7 is a positive 35. Now, to be in standard form, the two variables have to be on the same side. Remember, standard form looks like this. ax plus by is equal to some number. Okay, so both of the variables have to be on the left-hand side. So what I want to do is I want to move this over to this side by adding it to both sides. So we get 3x plus 7y is equal to 35. And that is standard form. Let's try another. I got a problem. So y minus 2. Now we have a point slope form equals negative 1/3 times x plus 6. Couple options here. I could distribute the 1/3 and then add the 2 to both sides to put it in points, to put it in slope-intercept, but I don't have to do that. I can just cancel out this 1/3 by multiplying both sides by negative 3. And the reason why I picked negative 3 is it'll cancel out the negative 1/3 and make it positive. And then I have to multiply this side by negative 3 as well. Because these are 3 different terms, I could distribute this first and then distribute the 3, but basically if I multiply these two first, negative 3 times 1/3 just goes away. And because of the commutative property, I'm allowed to do that. So that's x plus 6. Okay? This turns into negative 3y plus 6. Now, I want to get the variable over here. I want to get all the numbers over there. So that gives me a minus 6 on both sides, which would make the number go away. Which is okay. So we get we get negative 3y is equal to x, and then subtract x from both sides, and we get negative x minus 3y is equal to 0. However, it is good form to always have your leading coefficient be positive. So I'm going to multiply both sides of this equation by negative 1. Okay? 0 times negative 1 is still going to be a 0, but the left side will turn into x plus 3y. Definitely a little bit cleaner. Okay? So let's use standard form to make, or as a model. Okay? So a media download store sells songs for $1 each and movies for $12 each. You have $60 to spend. Write and graph an equation that describes the items you can purchase. What are three combinations of numbers of songs and movies that you could purchase? So let X is going to be songs. Y is going to be movies. Okay, so if we think about our situation here, $1 each for songs. So that's 1 times X, which is just X. $12 each for movies plus 12Y is going to equal 60 bucks. That's all the money I got. All right. So if I wanted to graph this, I could find my X and my y-intercept, since this is an equation in standard form. My x-intercept, I would plug 0 in for y. So I would get X is equal to 60. For my y-intercept, I would plug 0 in for X. So I would get 12Y is equal to 60. So Y is going to be equal to 5. Okay. So that means that I could buy 60 songs and no movies to make one of my coordinates, 60, comma, 0. I could buy no movies, or sorry, no songs and 5 movies, which would make my equation 0, comma 5. Right? Then, as I graph them, any of the points that line up exactly on my graph are going to be other combinations. So it's going to be kind of hard to tell with a graph of this sort of size. Remember, we don't need negatives because it's not possible to buy negative songs or negative movies. Movies, I know my graph is only going to go from 1, 2, 3, 4, 5. So we're gonna have a point right there. 1, 2, 3, 4, 5 for movies. Songs. Right? Let's go by sixes, or let's go by 12s. Because hey, look, $12. So 12, 24, 36, 48, 60. So that's 12, 24, 48, 12, 24, 36, 48. Okay, so now I know I have a point over there. I have a point right there. And I can just connect the lines. And now, as you see right here, the dots on their lines kind of all line up. And we could buy 4 movies, 12 songs, 3 movies, 24 songs, 2 movies, 36, 1 movie, 48, and 0, 60. Okay, so we have some nice points provided that, we have our y-axis go up by 1 and my x-axis go up by 12. We keep everything nice and balanced, and we make a nice picture. Okay. In problem 5, suppose the store charged $15 for each movie. What equation describes the number of songs and movies you can purchase? Okay, so now we are going to we're still going to have that the songs are $1 each. We just are charging $15 for the movie. So my equation is going to be x plus 15y is equal to still 60. Okay, so that means that x is still going to be 60, my x-intercept. But my y-intercept is going to be 15y is equal to 60. If I plug 0 in for x, divide out the 15, and I get that y is equal to 4. Okay. So I can buy 4 movies or 60 songs or some combination of the two. What domain and range are reasonable for the equation in part A? So my domain is all my x values. So because I go up to 60 and I can't buy a negative amount of songs, my domain is going to be, if we remember this, x such that x is greater than or equal to 0, right? You can buy no songs. Okay, so there's my domain, that x is in between 0 and 60. My range as a set is y such that, well, can I buy 0 movies? Yep. And I can buy up to 4 movies. Because that's all the money I got. Okay. Not sure if we went over this notation or not. This is set builder notation in case you don't remember. Okay. So quick summary. You can graph any line using one or more of these forms of linear equations. Any two equations for the same line are equivalent. So like we said at the beginning, we have slope-intercept form, which deals with the slope and the y-intercept. We have point-slope form, which deals with the slope and any other point on the line, right? 3, 4. And standard form, which deals with the two intercepts. So 2x plus 3y is equal to 18. All three of these equations right here are the equation of this red line. It doesn't matter which form we use. And as you get a little practice with this, you can see which form works best in each situation. All right, so let's do our lesson check. What are the x and y intercepts of the graph? 3x minus 4y is equal to 9. So we plug 0 in for x, so we get 4y is equal to 9. Divide by negative 4. So that's y is equal to negative 9 over 4. And my x-intercept, or sorry, my y-intercept is going to be, my x-intercept is 3x equal 9. Divide out the 3, and we get x is equal to 3. So my x-intercept is 3, my y-intercept is 9, negative 9 over 4. Graphing that, I don't want to go through a whole graph again, right? When we graph it, we find an intercept. It's going to be 5 and 3, and we just make a line right that. Okay. Is the graph y is equal to negative 0.5, horizontal, vertical, or neither? Well, it's not neither because there's no x. If you only have one letter, it's going to be either horizontal or vertical. And if you have y is equal to something, it is a horizontal line. If you have x is equal to something, it is a vertical line. So this one is horizontal. All right, let's do this one. Y is equal to 1/2 x plus 3. I have a 2 in the denominator. I'm going to multiply this whole equation, everything, by 2 to clear the fraction. So that's 2y is equal to x plus 6. And then move the x to the other side. Subtract x from both sides. So that's negative x plus 2y is equal to 6. However, it is a good practice to get into to realize that you should not leave an equation off with a leading coefficient being negative. So we're going to take everything here and multiply it by negative 1, which makes this x minus 2y is equal to negative 6. You're probably wondering why you have to do that last step. It's just good form to not start off with a negative number. Good grammar. Okay. Store sells gift cards in preset amounts. You can purchase gift cards for $10 or $25. You have spent $285. Write an equation in standard form to write this situation. So we have 10x plus 25y is equal to 285, sorry. Okay. Which is an equation in standard form. Okay. And then plug numbers in and you can get the intercepts and other points on the graph. Tell whether each linear equation is in slope-intercept form, point-slope form, or standard form. A is in point-slope, and the slope is negative 1. Y by itself means slope-intercept. Point-slope, when you have a situation like this with a parenthesis, and when x and y are on the same side equaling to a number, that is standard. So, point-slope, slope-intercept, standard form. Which form would you use to write an equation of the line on the right? Well, this is uh, this is a tough one. Um, Personally, I would go with slope intercept because I have the intercept and I have a couple ways to get the slope. The next best thing is maybe um, point slope because you can easily tell the slope. Standard form is usually not the form that you want to jump out at and try to write an equation with. If you see a picture and you have a clear y-intercept, you should be able to find the slope. Slope-intercept form is usually the easiest way to write the equation. If you had to, go with point slope. Standard form is going to be good for other stuff that we're going to do, like solving a system of equations in the next chapter, but it's not as useful for writing equations from graphs. Okay? And that was 5-5, standard form.